So a couple of words about my talk here. This comes from my background and my experience with building and developing some of the cloud pipelines for our offerings. I used to be an image architect for Smart Cloud Enterprise back 8, 9, 10 years ago. And I had to write most of this using Perl, which is not a very, very nice way of doing it. And meantime, the landscape has changed. We have new tools. We have new ways of doing and building things. So what I'm going to walk you through is a workflow. So there's a lot of ways of building and deploying things to cloud. There's a lot of ways of packaging applications. One workflow I particularly like and enjoy using is basically a mixed workflow, where you're building master golden images. So you're building an operating system, you're keeping that up to date, but you're also packaging, containerizing, deploying, and automating some of your application stack as well. So I'm going to start and I'll kick this off with Packer for image build automation. Just show of hands who's ever used Packer before. Oh, that's quite a lot of people. So who's used an alternative to Packer? So who's built and used things like Kickstart or Debian auto install to automate? So a couple of names here as well. Yeah. So first, a couple of things about the problem statement. This is a personal talk. This is for my own private cloud environment. This is not something that we use in production, so the talk isn't affiliated with my employer or anything like that. I got on eBay. I shouldn't have got on eBay. That was a mistake, a very costly mistake, a very heavy mistake to make. So I ended up buying a couple of, let's call them dev and test environments for training. So who knows what the stuff on top is, the two boxes on top? Show of hands. So those are tape libraries. So I was fascinated with tape libraries. I bought two LTO7 and LTO4 tape libraries there, and I decided, well, I'm going to build and maintain my own private cloud, maybe with something horrible like OpenStack, and see how it goes. Maybe I'm going to go into KVM, or ended up with going with all of the above. Unfortunately, I also ended up buying a full-size rack. So this was the beginning, and it ended up growing and growing. One thing I found is, if you can see some of the switches there on top, the smaller the device, the more noise it generates. So that's an interesting fact. You see, if it's a one-U device, you'd think, hey, that's not going to make a lot of noise. Au contraire. What happens is they put fans on those things, and if it's a one-U device, they will go at 11,000 RPM, and it's going to take off. Not fun. I also figure out there's a maximum power rating on the things around the living room, so you have to get power from different sources. That's another fun fact you learn as you build these things. I also ended up buying one of those data center in a box blade centers. I have like a G7, which is rated at, I don't know, something like 5,000 watts. Not an easy thing to power off, and when you power it off, you start suddenly seeing things fly through your room and through your house. It's an interesting thing. So I ended up saying, okay, fine. So I have this environment, I'm going to use it to build things, but I'm going to move this to cloud. So what I ended up is I bought a shipping container, I put everything in a shipping container, not a Docker container, and I started moving more and more towards cloud. So now I have a new workflow that I use to build and generate some of my images, and it goes a bit like this. So everything is code. So infrastructure is code, pipeline is code. Everything that you do needs to be under a version control system like Git, and once you make a check-in, then it pushes the system through. No change that you make in production or in any of the environments should be done manually. And here's some of the tools that I use to make this happen. So first is Packer and OpenSCAP. Who's used OpenSCAP before? Okay, who's in security? Who works in security? Show of hands, look into Packer. So if you're in security, think about a tool that can generate Ansible recipes to remediate your environment and apply anything from HIPAA to PCI compliance to security rules automatically. It's amazing. And it's what I use to secure some of the base images here. Then we have Ansible and molecules. So Ansible is amazing. It can be used to automate just about anything. Think network devices, infrastructure, cloud. So today, if you go to the list of modules for Ansible, you'll find there are over 3,000 integrations out of the box. Want to write your own integration? You don't have to. Somebody's already written it. And if you want to write your own playbook, you go to Ansible Galaxy and you'll find something close to 300,000 existing recipes. You take them. Now, half of them are written by this guy called Girling Guy in the US. He's really, he's really something. So if you've used Ansible, you've probably seen his face around. He's got a great book. But Ansible is the way that I like to automate the configuration management of everything from applications to Kubernetes to containers to OpenShift to environments to even doing things like installing Python modules, for example. Who here has set up their own Python workstation manually using something like Anaconda Python? Show of hands. Don't raise your hand. You're at the Python conference. Come on. Everybody. So who's done it more than once? You see my hand is down. I don't do it more than once now. Everything I do, I automate using Ansible. And if I need to reproduce it, I just give somebody an Ansible recipe, or I give him an image, or I give her a environment or a Vagrant box or a system where everything is already automated and part of the pipeline. So if you're doing things like you have your own dev and test environment and you're installing those or reconfiguring those, here's another chance. And if you ever used something called Eclipse Che or code-ready workspaces from Red Hat, you'll find that even Visual Studio plugins are integrated as part of the Web ID and they are part of the framework. So developers no longer have to set up their own development environment. And even this laptop is actually managed by Ansible. So, and this talk, it's automated, it's written in Markdown, it's part of a Travis CI pipeline. I check in a new version. So if I switch here just for a second, you'll actually see how this talk is being built. So this talk, is built using a CI/CD type workflow. So that's the goal. We're going to automate everything today, and we're going to see what kind of options we have. So let's kick it off with Packer. Image build automation. So this is basically Packer at a glance. So a couple of things. I've been asked to point at this screen, so I'm going to point at this screen. First, we have the specification for Packer. This is a JSON document. Now, they're working on different formats based on HashiCorp's experience with Terraform, but basically you have one source document that you write in JSON. Next, you have something called communicators. So communicators use either SSH or WinRM or some other technology to communicate with an environment that's being built. So what do I mean? Packer has something. I shouldn't point at my screen, should I? Maybe I should make an AI algorithm that I point a laser at my screen and it points it back. It's very uncomfortable. So builders. So everything can be a builder. I can use KVM. I can use Xen, AWS, Azure, any cloud provider, Docker. I can use VirtualBox, DigitalOcean, IBM Cloud, doesn't matter. I can use it as a builder. And what Packer will do is will take my JSON specification where I say, I want to build an image for Red Hat Enterprise Linux, for CentOS, for Ubuntu. I want to build a Docker container. I want to build something. It will go to the builder. It will spin it up, instantiate it, and then what it does is it automates the installation sequence. So if I use Kickstart, it will literally type inst.ks, so I don't have to do it. So every time there's a new operating system, I change a variable in this, it goes, it builds it automatically for me. Now, that's not the fun part. That's just a base OS image. Everybody has a base OS image. What I'm going to do now is I'm going to call a provisioner on top of it. So I'm going to call Ansible. That's going to install all of my Python tools, all of my databases, my software, the stuff I need to have on the base image. Now I can have multiple image builds as part of my layers. Layer 1, base image. Layer 2, HIPAA compliant image or PCI compliant image. Layer 3, application stack 1, application stack 2, application stack 3. I've distributed the master golden images, and I have them available. This gives me the option to use immutable infrastructure. So who treats their servers and their instances and their development environments like pets? Show of hands. Do you know what that means? Yeah, so you take care of it. If you get sick, you nurse it, you give it aspirin, you give it an update and a security fix. Who treats it like a cattle? There we go. So what does that mean? If it gets sick, we do what? Shoot it in the head. That's the right answer. These are throwaway environments. Even your build pipeline. Most of the build tools that use Docs or GitLab, online see how these things are built. Right. So it's a container, it's an ephemeral instance. You go in there, you throw the build things. So even if you use Jenkins today, you'll find that some of the worker nodes for Jenkins are just ephemeral containers. It does the job, then it disappears. If you're using cloud, you get to save a lot of money, so that's also very, very good. Now, post-processors. Once I have my image built, does it help if my image remains on my laptop or if it remains on my build server? Well, not so much. So we've talked about GitOps before. We've talked that once I make a check-in, if it passes every single stage of my testing, of my verification, of my static analysis, it should flow into production. Now, maybe there's a guy there that says yes or no. That's a manual verification step. But I want to have a post-processor for my image. So a post-processor might compress my image, might put it in a Vagrant, might upload it to Docker Hub, might upload it to an AMI. Am I saying that right? AMI? Am Fun times. So let's take a look a bit at a Packer specification. So first you want to have parameterized builds. If you're not parameterizing your builds, then it's not very useful, right? So here's an example. Variables, environment, my secret. So I'm using secrets. Now, secrets can be held in a secret store. I can use HashiCorp Vault. I can use it. So what would be in a secret? Maybe the root password for the image I'm building. Maybe I'm using CloudKit, which is a Python tool to automate some of these images. But you don't necessarily want to have them as part of your build logs and in plain text. So here's where you can use parameters as part of your build. Now, once I've parameterized my build and I've given it all of the other options, I now have my builders. How many builders can I have? As many as I want. So I can build 100 images in parallel. Fairly easy process. I'm going to start with VirtualBox. I assume everybody used VirtualBox or KVM or VMware or anything like that. Now, these Mario instructions here, up, wait, tab, jump, eat mushroom, those are basically typed by Packer directly into the console. So when it starts the VM, it will basically up arrow, wait, tab. That basically means grub prompt. I want to edit grub, and I want to kick off this parameterized things. These things are variable. Don't be scared. It's like a Jinja 2-like template. So these come from HTTP IP is the IP, the port, user, and CFG. CFG is a file I've created. It's a Kickstart file or a Debian auto install file or something to automate my installation. Now, I can also have provisioners. So once I finish the installation, I just have a Kickstarted OS. That's not very fun. So I'm going to kick it up a notch. I'm going to have a shell script and an Ansible script. Why? Because I'm lazy. I haven't automated everything with Ansible, so I'm just going to have shell script for a couple of things, and then I'm going to have an Ansible, and then a chef, and then a Puppet, and whatever I want. Now, I typically only do this Ansible stuff as I want to have everything idempotent. I want to have everything reproducible. I want to have everything, but sometimes you're working with sysadmins, and they want to do it quick and dirty. If you can't do it instead, an awk is not worth doing. And why both? Because, you know. So now I have an image. I have installed my middleware. I've secured my image. So at the previous step, perhaps I've also applied the PCI compliance, HIPAA compliance, stuff like that. Next, I want to do something with this. I'm going to compress my image, and I'm going to upload it. Or perhaps I'm going to convert my image to a specific format of one cloud provider, add some metadata, and trigger the next step of the build. And perhaps, as part of my post process, I'm going to have a hook that triggers the next part of the build, which is going to be testing. So I'm going to deploy it, and I'm going to test it. So how does this look like? So I'm going to try to do a very interesting live demo now. So hopefully everything is working. So let me show you the screen first, because it might not work, because I'm going to do it on my laptop. So basically, I'm triggering a build for VirtualBox ISO. VirtualBox kicks up, and it's basically going to start doing everything here. So let's watch this in action while I take questions. So, builder. Now, I have files here. Files are my Vagrant file, because I'm using Vagrant to show you how this works. HTTP is where I serve the Kickstart file. So here, for example, CentOS recently came out. I have a Kickstart file for CentOS, and you can see I'm using the password. Quickly write that down. It's encrypted, but you can probably tell it's Vagrant. And I'm also going to have provisioners. So in provisioners, I have Ansible. So you can see a playbook, for example, which just installs VM tools. Who can guess what VM tools are? So it's basically going to say, is this KVM, VMware, or VirtualBox? And if it's VirtualBox, it's going to download the tools. If it's KVM, it's going to download. If it's cloud, it's going to do something else. So I'm using one source build, but depending on what I'm building, could be multiple things at once, it's going to go down different paths. I also have a PCI compliance in place, so if you're working in financial services or healthcare or some other domain, you probably want to have items compliant. And if your development environment is not compliant and your production environment is compliant, SE Linux, anyone? Show of hands, who's using SE Linux? In development? A couple of hands gone down, huh? Now, what happens if your development environment is not compliant and your production environment is compliant? You're going to have a bad time. So you're going to deploy in production and go, well, it works on my machine. Well, of course it does. You're wide open, everything is not secure, everything is talking to each other, you're not using SE Linux. So I want to make everything secure and compliant. And last but not least, I have my specifications here. So let's take show of hands. Who likes Red Hat, CentOS, Fedora? I'm going to do this Python conference. Huh? Ubuntu? Ah, damn it. Fine. Fine. Developers, I see. So basically, I have some variables here, like the download ISO, the URL, so I'm going to grab it straight off the internet, or if it's cached locally. SHA sum. Who here checks the SHA sum and GPG? Okay, laughs already, huh? Hello. Nice to meet you. You too. You probably are not developers. Yeah. So automating this kind of pipeline does actually help ensure that you're securing and you have traceability of everything. So who's used Mint Linux? 2 years ago? Did you GPG check when they inserted that Trojan? Do you know what Trojan? You know what Trojan. And you GPG checked, right? Did you start GPG checking after? Yeah, okay. And you're still doing it today? Okay, that's good. Who here uses Python? Python conference. Who knows about the stuff in pip that went up? That was, okay, so a couple of names, right? So traceability helps ensure that whatever you deploy in production has gone through at least a process of validating and the process of checking, sanity checking. Even if you will get compromised, at least you know how and when and what servers are compromised, what builds are compromised. So everything here is part of a build process. Everything has a sum at the end, and I have my playbooks. I know exactly what is happening at what point in time. So next we have the builders. I have a null builder just to test my recipe, a VirtualBox builder. As you can see, fairly straightforward. This is basically doing some guest additions, keeping it registered, VM size. This is just the VM size for the builder itself. And here is where all of the magic happens. Now, the reason I wanted to do Red Hat is because it has a sane installer. It's called Kickstart. None of this nonsense. Look at this. It's horrible. They're replacing it with YAML because of reasons. And right now, it doesn't work. So if you have the latest version of Ubuntu, you have a Debian auto install and a YAML-based install, and both do half of the job. Not fun. But it's starting to look better. So I can automate some of these things. Now, since I don't have all of the capabilities in my Debian auto install, I'm going to come with Ansible and polish it off at the end. So who can guess what's going to happen next? So checksums, a bunch more checksums. So here's some VMware. This can work for vCenter or other environments as well. I can have different build environments. So right now I'm using IBM Cloud where I have bare metal servers. So I have big beefy Xeon servers where I'm doing my builds because I have KVM and I have Xen and I have on the same machine. But I could be using different nodes. So I could have an Azure node here. I could have a AWS node here, so I have multiple builders. I have different versions of VMware, perhaps. And this can help if you're also distributing an application to things like Vagrant or AMIs or something like that. So here's my KVM. Now QEMU is basically KVM, Xen, AWS, same builder for all of them here. And now I have my provisioners and post processors. So I'm just using simple provisioner and shell here and a post processor, which will give me a build number and do some very magic things in very horrible syntax. Whoever invented this kind of Ruby-like, Jinja-like thing is definitely masochistic there. So I'm going to trigger the build. So as you can see, I can do a make -j10. So I've written a make file for this to do it in parallel, and it's just going to spin up 100 things on this laptop. It will melt through the floor. So let's give it a go. All right, there it is. Starting off, running, and I'm just gonna breathe a bit because I gave it a timeout. Look, ma, no hands, nothing happening. See? Not a video, I promise. So this does it for me, and it does it for me every day. So every time I deploy an image in production, it's updated. Now, what happens if I deploy an image in production and it's not already updated, and I update it after? What would a hacker do with that information? With that window of vulnerability? There's chances, and I've seen this happen in real life before, that images people deploy in production get compromised before you get access to them. So let me state that again. You have an image, you've built your image, or you're using a standard AMI or some other image, and you've deployed it. You're in the provisioning process. Before you're able to SSH into the image, it's already compromised. This has happened. Now, it doesn't normally happen with services like SSH, which are secure by default and usually go through a good code audit because there's a guy named Theo, and he's probably going to get in trouble soon when he calls everyone assholes. But basically, that's how it works. People in security, they hammer it down. But perhaps you're running gUnicorn on this image. Perhaps you're running some other application server that isn't as secure or has the need for more frequent updates. So you've deployed your application, and by the time you have access to it or do even an update, it's already in the hands of somebody else. So, oopsie, that's not good. I think I might have did a make without typing a specific OS. So instead of making Ubuntu, I'm making everything. I swear this was part of the demo. So if things slow down, it's because of this. But as you can see now, I have CentOS 7, 8, RHEL 8, Fedora 30, Ubuntu, and no control over my machine. So now I should have really used the cloud here. So it works on my machine. Are we going to ship your machine? And thus Docker was born. So I have another build node that's remote, so I think it's good enough. So next step, how are we doing on time? I'll take that as we're OK. OpenSCAP. What the hell is OpenSCAP and why do I need it? So here's the idea. We have a system, but it's not necessarily secure. Or if you're working in a bank or a specific financial institution or some other environment, it doesn't go through the checklist which says it's secure. Big difference. Compliance, security, not necessarily the same thing, both important. So let's take a look at this thing called OpenSCAP. So what I've done is, as part of one of the builds, here's one I made before, like in a cooking show, I've ran an evaluation report on a system that I just built or on a system that you can find with any cloud provider. So how compliant do you think it is by default? Well, the answer's on the screen, but anyway, about 50% compliant with everything. So I'm matching all of the rule sets. So I'm going to start looking at something a bit more specific. So, all right, FBI, I'm not FBI. ISO 27001, PCI DSS. This is the one that everybody knows, loves. If you're processing any kind of credit cards or payment processing, you want to be PCI compliant. And I'm going to select here PCI compliant, and it tells me what passed, what was not checked, and what has failed. So, for example, I don't have a deny for failed password attempts. Why not? Because I type my password like this, wrong, and I'm out. Or I don't care. Well, if you're in PCI, you need to set this up. Do you know how to do it? Probably not. You don't have to. This does it for me. So I'm going to click this, and I'm going to see what the hell this is about. So, PAM. Who's used PAM? All right, a lot of Linux geeks there. PAM is fun. You can do second factor authentication on your laptop. You can use it with various tools. It's a pluggable authentication module for Linux. So it can also do things like lock people out or perform checks. So here's a very easy way to do it. This is all you need to do, right? Oh, Jesus. This is, all right, not fun. So instead of that, I'm going to do this. This thing is an Ansible playbook. It just generated for me that will set the fail lock automatically. So instead of me starting to write all those things to secure all my servers and then take into account this might be Linux, this might be a different distribution, this might be a different OS, I'm just going to make this rule as part of my build. And same thing if you want for any other things like verify all passwords are hashed, prevent login of accounts with empty password, limit password reuse. I really hate this one. So in our company, we recently implemented 16-character password rules that are changed every month. And I VPN in, and my laptop doesn't have an RJ45. So, and for wireless, we use certificates. So guess what? When something expires, everything expires. My Wi-Fi, my network connectivity, my VPN access. And it's usually fun when you come back from vacation and you can't access your email. And of course, if you need to reset your password, you just write an email. Oh, shit. Oh. So sometimes security folks can go overboard. And you know, if you type your password 10 times, you might delete everything because it's encrypted and say, ooh, hackers. But sometimes you need to do these things. But if you're just doing them in one environment, then the behavior you get in development and behavior you get in production isn't good. Who's heard of DevOps? What's DevOps? Or DevSecOps, just to include the security folks. It's developers having root access in production, right? Right. So it's basically developers, operations, security, business folks working together jointly and owning a product all the way from development to production. But in order for that to work successfully, development and production need to look the same. Because the experience that you're building in development and the experience that you're building in production, well, you might have different points of view. Your operations guy will say, I have a high availability cluster with multiple nodes, with monitoring, observability, all the fun, fancy things. The developer says it works on my machine. I'm using Windows, I'm using Python notebook, and I'm deploying to a Kubernetes cluster with an application that auto-scales different database, and I'm not using SQLite, and things are different. And all the security things and network connectivity rules that you might run into production, well, you don't want to test in production. I mean, I just found how this works in production with the same team at 3 a.m. Now, I used to be in operations for a long time, and the fun thing about operation was this. 2x my daily rate after hours, 3x on weekends, 0.25 just to be on call. So usually my overtime, and I was being paid twice as much than my salary. That was fun. Developers don't get overtime. So do you really want to have issues in production at 3 a.m.? And when you do have those issues, I remember an incident where we had an issue and we were going around the cloud like Japan and India and this and country and country and country, and I did 3 shifts, like 3 days, without sleep, trying to fix the issue. It was one of those fun, fancy issues where it sort of worked. That's the most fun to debug, where it kind of works, except it doesn't, and 5% of requests fail, and sometimes they don't fail, intermittent performance issues. Always, always fun. if you start adopting these practices and automating things and getting your DevOps teams to have access to production. Should developers have access to production in a DevOps team? Yes, but. Yes, but. The but is now you're running everything as you would in production. You're using infrastructure as code. You have your pipeline set up, and that's the mechanism through which you want your developers empowered. You want them to understand how production works. You want them to understand the sort of issues that you're dealing with. And then, when you're building a product with them, you're part of the team, and you're able to fix this type of issues. So, done with OpenSCAP. Oops. Now, Alt-Tab isn't the most responsive at this point, for reasons. So, you just install it, you run the report, and then you remediate it. So, on to Ansible. Why do we love Ansible? What's this thing about? So it's basically control, delegation, and scale. So what Ansible basically allows me to do is this: orchestration, configuration management, application deployment, continuous delivery, security, compliance. You can call OpenSCAP. You can do everything on everything. That's the idea. You write a recipe, you can automate your firewall, your infrastructure, your load balancer, your application deployment, end-to-end. Storage, network devices, whatever you need. So comes out of the box with integration to 3,000 different providers. Here's a small subset. If you have a cloud provider or any operating system in there, Ansible can manage it. It can perform the actions, and it can even work with Windows and Linux. The only rule is that it's a Python tool. So your control node is going to be usually Linux. It generates a Python script, puts it on the system over SSH or WinRM, and then it performs the changes. It can also run raw code, so it can just run SSH commands or shell commands, but those aren't usually as idempotent or powerful. I use it to bootstrap Ansible. So Ansible just needs Python, one dependency. But sometimes that doesn't exist or is the wrong version, so I use a raw script to make it bootstrap itself. Now, Ansible itself, you write a playbook. That playbook calls modules, plugins on an inventory, and then it performs the changes. If you want additional capabilities, you use something like Ansible Tower or ARX, which is the upstream open source version. Every product that basically has an upstream version, which is open source that you can use it. It helps you give some control over this, so who has access, identity management, logging, monitoring, and so on. So once you have this in place, you're able to do end-to-end automation of your environment. So let's take a look at an Ansible workflow and how this would go. So first, I'm going to install Ansible. Pip install Ansible, now I have it. Then I'm going to run some ad hoc commands. So ad hoc commands is like saying SSH server command. I run Ansible, I run the module call setup, and I run it on localhost. Module setup just gives me a lot of metadata, like 6 pages of stuff. This is basically everything Ansible knows about this system. I can also run different modules. So I can run Ansible -m yum -a package equals Python. State equals present. What does that do? Install Python. Now, you need Python to run Python. So here's where I would use the raw module instead. So I do a yum install Python if I don't have Python already. So how do I get started with Python, with Ansible? Very simple. Ansible doc -l lists 3,000 modules. Find the module you need, and then look at the help. So let's look at the module called pip. As expected, this installs applications from pip. So I can say name bottle, I can give it a virtual env and a command. I can give a specific version to it. I can make this idempotent. I can install it in a specific location. I can do it as a root user or as a local user. We probably want a local user. So fairly simple. If I need more information, I do a -s, and that basically gives me the snippet of all of the options that I have for this module. So for example, here you can see state, absence, force install, latest, and present. Latest will update. Present, if it's existing, don't mess with the version. I know you Python developers, if I change your version, everything breaks. So yeah, probably don't want to mess with that flag too much to keep your application idempotent. If it works on your machine with this version of TensorFlow and you're shipping it to production, you have a different version of TensorFlow, guess what? Probably won't work. So that's why I'm trying to package everything. Now, once I have everything in place, I can put it in a playbook YAML file where I say, here's the role I'm executing, and just execute it on more than one system. So here I'm just doing it on localhost, but I can also trigger an inventory. Now, to scale this model out, I can break down my playbook into multiple tasks. And I can group playbooks, I can group tasks, I can externalize my variables. So here's, for example, a install Red Hat packages, where Red Hat underscore packages is a variable. As you can imagine, I have a Ubuntu packages, I have a CentOS packages, and I detect the operating system, and I install different packages depending on the operating system. So here's a very simple example of how I can install KVM on a system using a parameterized build where I have some variables here and I have some tasks here. Now, you're also using variables to secure the secrets that you have in Ansible. So you can encrypt things like passwords and other things so they don't end up on GitHub, and then you have to figure out, how do I delete from GitHub? Well, yeah. The only thing that works is just delete the whole repo and put it again. Don't tell anyone. Now, testing. Who tests their automation? In production? No. How do you test it? Yeah. That's not bad. That's a good approach. So here's another approach you can use, which is Molecule. Molecule lets me test everything on my machine or on external systems in an automated fashion. Do you automate your tests? OK. So here's the way you do it with Molecule. I type molecule create Vagrant CentOS. I have a CentOS. I do converge. It runs the tests. And then I can log in and see what happened. So what does Molecule do? Well, Molecule is a plugin that you put on top of your Ansible recipe that can connect to a provider. So here's a provider for Docker. I have another provider for Vagrant, another provider for AWS, similar to Packer we've previously discussed, right? So when I run my Ansible recipe, it actually generates a Docker from this Docker file specification. It has the operating system I've selected. It brings in the Ansible playbook, runs it, and then runs Gauss or Python tests on top of it. So let's say I have a recipe. I'm going to show you one here, hopefully. If you don't mind, I'm going to quickly stop all of these. Power off. So what do I mean? Well, I have a recipe that installs pandoc. Pandoc is the converter I use to build these presentations. So it's a very simple thing. I have here molecule converge -s docker fedora 30. What you see, I just ran it before, it basically, it runs my playbook to install pandoc, then it unzips it, then it deletes the tarball, and then it runs some tests. Now, how do I know that an Ansible recipe is successful? If I install, for example, a tool called pandoc, I don't know that. So what I'm going to do is run a test. So I'm going to run pandoc ---- version. I'm going to check if it's the version that I installed, and it doesn't give me an error. So this is what Molecule lets you do. So let's take a look at Molecule here. I have various operating systems, and it's testing them all at once. So Debian, Fedora, RHEL, whatever it is. And then I have some tests. So here's an example. Test command for pandoc is going to check if the file exists and it has the right permissions. And then it's just going to check if stdout of pandoc --help contains pandoc. I can be more specific and place in a version and start to parameterize my tests. But here is how I know everything works fine. So if I want to take it up one notch, so I'm going to do, instead of converge, I'm going to do molecule login. And now I have, oops, I got that release. There we go. Now I have a container. All right, so. So now I'm going to get one for Ubuntu, and it's going to start building my environment for Ubuntu, and then I can log in and test it. So I just tested 2 distributions in 2 seconds, which is fairly impressive. Test your stuff, test your code, test your automation, use Molecule. Molecule also has integration with Cookie Cutter. Who's used Cookie Cutter for Python? Right. So if you're writing roles for Ansible, take this one and type Molecule init, Cookie Cutter, role HTTPD. You have an HTTPD role with all of the tests, with Molecule in place, with everything you need, parameterized. It will ask you for your name, for the license you want, and you don't have to recreate all of the boilerplate. Vagrant. Now that we have everything in place, we can actually test the images that we've built. So while this thing is building here, I'm just going to show you just what Vagrant is. So if you've used Vagrant, you can now test. So builder, packer, test. So I have a test here. Let's say Ubuntu 18.04, Vagrant up, and now I should have, I probably shouldn't keep starting all of these VMs. Basically, the OS I've just built, within 2 seconds, is going to bring it up, so I can play with it manually. I can do my manual test before I push it onto my cloud provider. Now, remember, I'm building the same image for VirtualBox, the same image for VMware, the same image for cloud. So even if I'm using one virtual tool here, I'm still able to test some of the same things. Now, how are we doing on time? 5 minutes. So let's blaze through the other part of the pipeline. How do you do the rest of your automation? Now you have a secure base for your code. Let's deploy our code. So Python. You know how to package things with setup tools. You know how to build images. But are you automating that as well? Are you using Ansible? Are you using static analysis? Are you building, packaging, deploying, testing your application? So when you do a Git commit, it goes all the way to production with all of the steps that you would do manually. So this deck will be up here. You know how to automate things with setup CFG. Now let's integrate some unit tests. So I'm going to use Tox here to integrate tests across Py 3.5, 3.6, 3.7, and automate some of my testing. Then I'm going to use something like Travis or Jenkins to automate my build. And I'm going to use some tools like Black or Yaps to automate my code rules. So Black, who's used Black? Look into it. If you haven't used it, it's awesome. It makes your Python code follow a standard. Everything will look nice. You run a command, it's compliant. I put it in my pipeline. So if I have 10 developers, they use 10 different standards. One standard, one tool, Black. Or I can use something like Yap, and I want to be fancy and work at Google, so whatever. Now, what other tools would we integrate as part of our CI/CD pipeline? So, Bandit, SonarQube, ZepScan, Arachne. Anyone who's into security, those are the tools you can use to ensure that your code is not vulnerable. You can include it as part of your CI/CD, gives out a report, shows the vulnerabilities. You need to look at the report and fix it yourself, but that's life. Other tools, testing, Selenium. If you're building a web application, you probably want to do the end-to-end tests. Packaging. Maybe you're going to deploy onto Kubernetes or a container, so maybe build a Helm chart as part of it. And then the deployment, Ansible, that's something you can use just to deploy everything to cloud. Depends on how you're packaging and deploying your application. Maybe you're building an AMI and destroying everything and using immutable infrastructure, but that's that. How do you make it easy? Cookie cutter. When you start a new project, you can just use a cookie cutter template. You say, I want to use PyTest, I want to do deployment with Travis. You've built all of this boilerplate, so every time you start a new project, you don't need to re-engineer it. So, last 5 minutes, I want to talk about Kubernetes. Who's deployed stuff onto Kubernetes? Who uses Kubernetes? Who can tell me what Kubernetes is? Yep, that's a great way of describing it. So Kubernetes lets us do something called resume-driven development. The moment you put Kubernetes in your CV, instantly Google will hire you and your salary goes up 30%. It's amazing. So if you haven't gotten into Kubernetes, That's the tip. By the way, I lead a team of cloud-native solutioners, so if you know Kubernetes, just send me your CV. Hello. I do multi-cloud solutions, so if you know AWS, Azure, different, but with Kubernetes on top, preferably OpenShift for reasons. So Kubernetes is desired state management. I tell Kubernetes I want to have 3 replica sets. I want to have my application behave like this. If this goes down, Kubernetes goes, ooh, I'm going to bring this back up. So I give it a state, and Kubernetes will match it. That's the simplest way of describing it. So this can help when you're building and deploying an application like Flask or whatever it is. You put it into a container, put it in a Helm chart, you deploy it into Kubernetes. Problems. Works on my machine. Do you have a Kubernetes cluster on your machine? Minikube. How many nodes do you have in Minikube? One, just the one. What kind of ingress controller? What kind of persistent storage layer? What kind of database? So it's not the same as production. So you probably want to look into some ways in which you can standardize the development, the build, the test. One way I found to be very helpful is just to put this as part of a big CI/CD pipeline. Instead of having to use Minikube, just use a throwaway environment with automation that helps speed everything up. So there's a lot of decisions that go. So for example, as of the last 3 or 4 years, everything IBM does and builds is on top of Kubernetes. So we've moved our Watson, our services. We run something like 70,000 clusters in production. We run them across, multi-zones, multiple data centers, multiple tiers. We do this at scale. And we found a lot of issues as the product matured and got more and more mature. Now it's reached a level where we can say reasonably that it's a good product that we can use it. But if you're not using the same environment to develop, build, and test your application, even if Kubernetes gives you the promise of, hey, it's one API, you might get into some trouble there. We also include the same kind of static analysis tools as part of our tool chain here. So for example, all of the images that we build, we have static analysis and checking, hey, should we deploy this container? It has a bunch of vulnerabilities. Do not deploy, so it's part of the automatic check. There's some new tools in place now, buildah, if you've used some of the new cryo stuff, so you can build images a lot easier and build your application. So I'm going to leave you with a couple of words. DevOps is not a product you can buy. DevOps is a practice, it's a culture, it's something that you need to live and breathe. If you want to take a look at some of these items, you'll find here openpracticelibrary.com. I highly recommend it. It's built by our colleagues at Red Hat, but anyone can contribute to it. So it's an open source project. All of the frameworks, all of the methods are available here, and you can use them to build great software. You can tweet at me, and if you're interested about that last stuff, for cloud solutioners, high-level stuff, multi-cloud, Kubernetes, cloud native, just find me on LinkedIn. We can have a discussion.